Okay, 2.3a, conditional statements. Our objective today is students will be able to recognize and write conditional statements and their converses by completing a group activity. And that's something we're going to do in class. Okay, well, let's get on to the notes. Conditional statements basics. All right, some basics. Well, conditional statements, these are if-then statements. So example, if you are in this class, then you are taking geometry. So the hypothesis, that is the if part of the statement, and the conclusion, that is the then part of the statement. Notice we did not include the if or the then in the hypothesis or the conclusion. So for example, right here, the you are in this class, that is the hypothesis, not the if. And the then you are taking geometry, that's the conclusion. We don't include the then part. Okay, so just this part after the then and just this part after the if. All right. Identify the hypothesis and conclusion in the conditional statement. Example number 1. If it is sunny, then it is daytime. Hypothesis. I don't include the if part there. Instead, I only include the it is sunny part in the hypothesis. And the conclusion then is just the it is daytime. Alright, so I only use the part after the if for the hypothesis, and I only use the part after the then for the conclusion. I'm going to have you guys pause the video and see if you can do practice number 1 on your own. It says if y minus 3 equals 5, then y equals 8. Go ahead and pause and try it on your own. Okay, for your hypothesis, you should have had y minus 3 equals 5. And for your conclusion, you should have had y equals 8. Not too bad, right? Let's keep going. Next says, write each sentence as a conditional statement. An integer that ends with 0 is divisible by 5. Alright, so we got to change this to an if-then statement. That's what they mean by a conditional statement. So, I'm going to say if an integer ends with 0, then it is divisible by 5. Alright, notice I said an integer ends with 0, that is now my hypothesis, and it is divisible by 5 is now my conclusion. I just added an if-then in there in the appropriate places and changed it into a conditional statement. So what I want you guys to do is go ahead and do that with the next statement, practice number 2. It says a square has 4 congruent sides, so go ahead and do that and pause the video now. Okay, well you should have got something like this. You could have said if something is a square, or if it is a square, then it has 4, and I'm going to use some shorthand here, 4 congruent sides. So if you had something like that, that's pretty good. Again, like I said, you could have put if something is a square, or if the shape is a square. You could have done a lot of different things there instead of it, but the main thing is that we wanted if it's a square, then it has 4 congruent sides. Okay, let's move on to validity. So we got to go over this topic of truth value, and that is basically just how true a conditional statement is, because as we go through conditional statements, we're going to find that some are more true than others. So let me pause and go to the next slide. Okay, so it says determine the truth value of the conditional statements. First one says, if it is sunny, then it is daytime. Let's think about that. Yeah, usually if it's sunny, then it is daytime. But is there anywhere in the world where it's sunny out and maybe it's not actually daytime? And that's true, actually. There are places in the world where it's sunny and it's not daytime. So we would say maybe this is not always true, because there's places like Alaska. There are places like Alaska where it stays sunny all night long. And in certain parts of the summer, the sun never goes down. And so it would be sunny out. So it would still be sunny, but it wouldn't actually be daytime. It would still technically be nighttime. And so this statement is not always true. And in order for a conditional statement to be true, it has to always be true. And this one is not always true. Let's try the next example. It says, if y minus 3 equals 5, then y equals 8. Is this always true? Well, yeah, this is always true. If I was to plug in, or if I was to solve this equation, y minus 3, right, I was to add 3, I would get that y has to equal 8. And that's the only thing that it could be. And so this is always true. It's always true. That never changes. All right. Next term that we're going to need to learn, and we're going to use this a lot throughout geometry, is the term a counterexample. And this is an example that shows the conditional statement true. So mainly it's an example that shows the hypothesis true. So we're going to keep this hypothesis part true. Notice here in this first example we said, yeah, it's still sunny, but it's not daytime. It's still sunny, but it's not daytime. And so we need to keep the hypothesis true. An example that shows the hypothesis, and I ran out of room here, true, and the conclusion false. So Alaska here, Alaska is a counterexample to if it is sunny then it's daytime, right? Because we have Alaska, that's a time when the hypothesis was true, conclusion was false, so that's why it's a good counterexample. Next thing we're going to do is we're going to show the conditional statement is false by providing a counterexample. So I want you guys to try and do this on your own. List down a couple examples that you can think of, a couple counterexamples that show this statement is not true, right? That if you go to Buckingham, then you live in Vacaville, right? So we want to keep the hypothesis true, but we want to make the conclusion false. So we want to think of times when people do not live in Vacaville but still go to Buckingham. Okay, so go ahead and do that and pause the video. All right, well, there's any number of examples you could have come up with here, right? You could have said Fairfield. That's a town nearby. You could have said Winters. Maybe there's even some people in Davis. Basically, any town or city that's nearby that people drive to go to Buckingham, right? Any of those would have worked. All right, let's keep going. Let's talk about converse statements. Converse statements. This is when we switch the hypothesis and the conclusion. And I'm just abbreviating these because my handwriting is really big. But it's when we switch the hypothesis and the conclusion. So we're going to take the hypothesis part and just switch it out, swap it out with the conclusion part. So let me show you an example. First one says, if it is sunny as our hypothesis, then it is daytime is our conclusion. And we're going to just rewrite this as a converse. And so we're going to say, if it is daytime, then it is sunny. And if you can, ask yourself if that is a true statement, right? If it is daytime, then it is sunny. Is that true? Is it always sunny out when it's daytime? And if you think about it, that's obviously not true. There's a number of counterexamples we can list here, right? It could be raining out, and that would still be daytime, but not be sunny, right? Because it'd be real cloudy. It could be an eclipse, right? So I've heard that one before. Like, it's still daytime, but it's not sunny because the sun's covered up by the moon. It could actually, we could go back to Alaska, because now in the winter, there's parts of Alaska where it's daytime, but it actually is dark outside and not sunny at all. So it's kind of interesting. So this one would not have a positive truth value. It would not be true. It's a statement that is not always true. I want you guys to do the practice number 5 on your own. If y minus 3 equals 5, then y equals 8. Go ahead and write the converse to that, and then ask yourself if it's still true or not. See if you think it still has a positive truth value. So go ahead and pause the video and try that. Okay, well, you should have come up with something like this. If y equals 8, then y minus 3 equals 5, right? We just simply switched the hypothesis and the conclusion. We swapped them out, and we got a new statement. This is the converse statement. Okay. I want you guys to go ahead and try practice number 6. It says, if two lines are not parallel and do not intersect, then they are skew. Let me just give you a hint, though. See this two lines? It's kind of like the subject of this sentence. So we're going to leave that with the if part. It just makes more sense that way. And you're only going to swap out the are not parallel and do not intersect and the they are skew. Try it. See what you get. Go ahead and pause the video and try that one on your own. Okay, well, let's see what you guys got. You would have had something like this. If, and like I said, you could just leave the two lines part with the hypothesis. That's okay. If two lines are skew, then they are not parallel and do not intersect down here. Yeah, if two lines are askew, then they are not parallel and do not intersect. There we go. Okay, what I'd like for you guys to do in closing is just kind of write a summary. Here's what I want you to write. Describe how to get a truth value of a conditional and converse statement. So figure out how you can evaluate whether an if-then statement is true or not, and whether its converse is true or not. Explain why it's important to understand the validity behind any conditional statements. Try and see if you can figure out why you think that's important. And I'll let you guys do that on your own, and see you guys next video.